right, so today actually we're going to do a little bit more of what we were doing, but this time they're going to be systems of inequalities, right? So the way in which we do this is you're going to have a system, you're going to graph and shade each one of these separately, and then you're going to take the regions that overlap. That's your solution, right? The solutions are the regions that overlap. So let's take a look at the first one first. So here, this one is y is less than or equal to negative 2x plus 5. All right, so plus 5, and then I go down to over 1. Now that's going to be dotted, not a dotted line, but a solid line, right? One sec. Okay. So here, all right, we're going to shade, because it's less than or equal to, we're going to shade below, right? So the way I do it is if I'm shading below, okay, it's all of this region here, correct? Now for the next one, it's greater than negative 1 over 4x minus 6. Minus 6 is here. I go up, down 1 over 4. 1, 2, 3, 4. This time it's a dotted line. Okay. And for this one, I'm going to shade above, right? Above means vertically up. Okay. Do you see that? So that goes here. Okay. This whole region for the blue. However, only one part of this overlaps, correct? The part that overlaps is the solution, which is right there. Here. Does this make sense? All right, so that is the solution, right? So all of the shaded red is the solution for the first. All of the shaded blue is the solution for the second. The solution to the system is the highlighted part, which is the part that overlaps. Okay, let's do the next ones. Here I have y is greater than or equal to negative 4x plus 8. So I'm going to go up to 8, down 4 over 1. Okay. And I'm going to shade above. So look, this is what I mean, right? Whenever you are confused like where to shade, when I say to put the arrows, it becomes less, like it becomes very clear when you just keep doing the straight up vertical arrows, right? So now it's very clear that this is where this is going to get shaded. The next one, negative 4x plus 4, I go down 4 over 1. This one is dotted. Correct? So where do I shade? Directly below. So here. Where is the part that overlaps? None of it. So this system has no solution because it doesn't overlap. Okay? You have to have a region to overlap. Okay, so let's do another one. Let's go ahead and do the next one. So for the next one, okay. We're going to switch things up a little bit, and then I'm going to show you a little bit more of an efficient way to do it, okay? So here we go. I have y is greater than or equal to absolute value of x. Okay, so absolute value of x, we know exactly how that looks, right? That's going to have a vertex here, right? And it's going to look like this. So that's going to be solid. Now, before you shade, okay, before you shade, look, this says greater than or equal to. That means I'm going to be shading vertically above. I'm okay with put little arrows like this. So now you can visualize where the shading of this was supposed to be. But I'm not going to shade just yet. Okay. Then the next one is less than 2x minus 6. Let me go down to 6. Okay. Up to over 1. And then I'm just going to put a little bit more, like a few more points. Okay. Like this. Right? I just put a few more points because I just want to make it more precise. This is going to be a dotted line. So there. Right? Look at where they intersect. Okay, now this one is less than. That means I'm going to be shading below. So do you see the arrows I put? I put one all the way up here, you know, at y equals 10, right? Like, look at the arrows I put along. So now I know where I'm going to shade. So can you visualize where the solution of this is going to be? Yeah. Where are they going to overlap? It's this sliver here, right? So then I can just shade that part and that will be my answer instead of like over here, you know, just shading. Now, it's completely up to you how you want to do this, but you know, this one at least keeps it a little bit cleaner. The bottom line is if somebody looks at your solution, it shouldn't be like, it should be super clear what you mean by your solution. All right, let's do the next one. Okay, now we have a parabola, right? So here, this one moves to the right 4 and up 7. Okay, so I go over 1, down 1. And if I go over 2, I go down 4. 4. Oh, sorry. Okay, sorry. Right? So I go over 4, down 7. So my vertex is at 4, 7. And then if I go over 1, I go down 1. If I go over 2, I go down 4. This is going to be dotted, right? And since it's less than, I'm going to shade vertically down like this. Okay? The next one is an absolute value. I go over 3, down 4. Over 3, down 4, 1, 2, here. And then I'm going to go up 1, over 1, up 1, over 1. Here. Here. This time, do I shade above or below? Up or down? Up. Shade up. So where is my solution? It's inside here, right? This is my solution. Okay? Any questions? All right, the point is it has to be super, super clean. All right, there should be no ambiguity where your solutions are. And then as far as the calculator is concerned, it's exactly similar, right? But you know, like there isn't anything different. Okay, so let's do this last one, this last page. Okay, so find the solution. Now we have 3 of them, but that's fine. Okay, we're gonna solve the equations for y. Here, I get y, negative y is greater than or equal to negative 2x minus 1. Y is less than or equal to 2x plus 1. Okay, let's do that one. 2x plus 1. Okay. Okay. And then for this one, I'm going to shade below, right? So let me just put those little guide arrows. Okay, next one. Y is less than or equal to negative x plus 4. So I go up 4. And then the slope is negative 1. Right? So like this. And this is going to be also solid. Am I going to shade above or below for this one? Below. Okay, vertically down. And then the last one, 4y is greater than or equal to negative x plus 4. Y is greater than or equal to negative 1 over 4x plus 1. Plus 1. So I'm going to go down 1 over 4. Also solid. Where am I going to shade this one? Above. So what's the solution? It's the little triangle here. Okay, and then the next question asks, what are the vertices of the triangle formed? And for this, it was absolutely necessary to do it precisely, right? And so the vertices of the triangle are now going to be 0, 1. This is for part B. 4, 0. And 1, 3. And obviously, the order in which you put them doesn't matter. You just have to do it right. Cool? Yes? Okay. Next, write a system of equations for the graph below. Okay, so let's do this. So first of all, let's do the red one first. It's an absolute value. I find those, it's more straightforward. So y, is it going to be, first of all, greater than or less than? Less than. Now, is it going to be less than or equal to? Less than or equal to. Okay, so the vertex is 0, negative 4. And then what's the slope? 2 over 1. So that's going to be 2 absolute value of x minus 5. Is that right? Yeah. Okay, for the parabola, remember I need to do the equations, right? So y equals a. Oh, thank you so much. Oh my gosh, it's okay. It's all right. Thank you so much. Okay. So y equals a, and then x minus h squared plus k. Okay, so what's the vertex here? 0, 7.
Oh, 7.
It's okay. I was reversing them. Okay, and then what's another point? I'm gonna pick this point. What point is this? 2, 3. Yep. Okay, so y is 7 equals a 2 minus 0 squared plus 0. No. K. What? No. This is 3. Oh my gosh. Boy, that had the potential to become a disaster. So now this is 7. Okay, now I have it right. Yes?
Yeah.
X and Y are 2, 3. H and K are 0, 7. Okay, so 3 equals 4a plus 7. Negative 4 equals 4a. A equals minus 1. So it's going to be y. Okay, what's the symbol going to be? What's the inequality? Less than. Okay, and then it's going to be y equals a, which is negative 1, x squared plus 7, like this. All right, so that's the equation. That's the system of inequalities. Okay?
Why do you lose the absolute?
Right? Okay, questions? Okay. All right, so there we go. So the homework for this is a worksheet. Hooray.